Hey there and welcome back to the C# for Total Noobs training course. In this lesson we will build of course upon of what we have done the last time, and we will continue actually the topic of arrays, but this time we will talk about multidimensional arrays. And I really don't want to get too deep into this type of concept because it's not something that you would necessarily encounter in your day-to-day programmer's life, but it's definitely a concept that it is very important, and it's very also important that we have an understanding on what those actually are. So in this case, let me just switch over, and as we have done previously, we will just have a very brief theory about what multidimensional arrays are, and then we will get our hands dirty and we will start also to code our examples and try to learn and grasp this concept of multidimensional arrays. So this being said, multidimensional arrays are nothing else than arrays, or a regular type of array that has actually more dimensions. What does this actually mean? Well, it means that we have here an array that contains different arrays. And what this means for us, it's maybe easier to understand or to grasp this concept if we think about multidimensional arrays as tables and matrices. But there's a catch here, because as the name suggests, it's multidimensional, so they could have more dimensions, not only two. The most popular, I would say, multidimensional arrays are of course the two-dimensional arrays, because there are a lot of use cases in programming where we would need this type of arrays. And this would mean that what a two-dimensional array is actually an array that contains two different arrays. So in this case, we can think about this 2D array as a table, like having rows and having columns like we see here. So we have here on the screen a representation of such a two-dimensional array that consists of two arrays. So this would be the first array, 5, 0, minus 2, 4, and this would be the second array, 5, 6, 7, and 8. And of course, if we try to imagine those arrays one under the other, then we can visualize it as a certain table. Like we have a row, each array in this multidimensional or in this 2D array actually represents a row, like we have this one and we have this one. And of course, then we can have columns, like this would be the first column, this would be the second column, this would be the third column, and this would be, of course, the fourth column. Now, the idea here is that in a regular array, we have seen that we can actually identify a certain element by its index. And not only identify, but through the index of that element, we can also change the value of the element and things similar to that. Now, of course, in a two-dimensional array, this actually doesn't really work, because in order to identify a certain value from that two-dimensional array, what we need to do is actually identify it by the row and the column where this specific element resides. So in this case, if we want to single out this element here, so the minus 2, we will have to access it via the row, which would be the index of 2, and then here the 0. So the row and the column, 2 and 0. If we want to identify 6, it would be 1 and 1. If we want to identify this 5, the first one, it would be 0 and 0. And then if we want to identify this 5, for instance, it would be 0 and 1. So the thing here is that we always have to identify a certain element by that specific index or combined index of the row and the column. And this applies specifically to two-dimensional arrays. Now, thing is that we can have also multiple dimensions in an array. Like each array in a multidimensional array represents a dimension. Now, in case of a two-dimensional array, what we have here on screen, it has a dimension of 2 because it contains actually two different arrays. Now, the idea is that we can have also 3D arrays, and in that case, we would have 3 different arrays in those arrays. And then we could have 4-dimensional arrays. Now, of course, 3-dimensional arrays we can't really visualize as a table, because actually Well, it's more like cube we can remember from mathematics. So here we need also to take the space into consideration if we want to visualize that. But the idea is that you can have arrays that span a lot of other dimensions, like 5 dimensions, 6 dimensions, 7 dimensions, and so on. And behind this, there is a lot of mathematical theory in which we will not go. But thing is, and what I want to actually draw as a conclusion here, is that probably the most common multidimensional array that we will encounter as developers is the two-dimensional array. And just to give you very short examples, for instance, if you want to build an application for a chess game, for instance, like a chess engine or a chess website, whatever, then you would have to represent most probably the chessboard as a two-dimensional array. But for instance, also when you work with different type of maps or things similar to maps, behind maps are actually graphs, and graphs can mathematically be then reverted to two-dimensional arrays, and then we can do a lot of different calculations on that and find different points and things like that. But the idea is that, well, there are very common scenarios in which you might use these two-dimensional arrays. Now, these are also known in mathematics as matrices or a matrix, and, well, more commonly also known as tables, as we have also discussed so far. Now, if it comes to multidimensional arrays, we declare them, and we will see this also in our code just in a few minutes, actually very similar to how we declare a regular array, but the only thing is here that in these brackets, for a two-dimensional array, we would have to use a comma. Like the comma is a delimiter, or we can imagine the comma here like a delimiter between the different dimensions. And here we have then one dimension before the comma and one dimension, of course, after the comma. And this would be then a matrix or a 2D array of integers. This would be a 2D array of floating point numbers. And then here, for instance, we see that we have two commas. And this would mean that we would have one dimension before the first comma, one dimension before the second comma, and then we would have a third dimension after it. So this means that in this case, we have a three-dimensional array, which we can also call a cube. And in this case, it is of type string. So all elements in this three-dimensional array should be then of type string. Now, when we also want to instantiate the array, because what we have done here is we have only declared them, if we want to instantiate them, as previously said when we discussed arrays are fixed size. This applies also to multidimensional arrays. So the only new thing here that we have in multidimensional arrays is that, for instance, for the first int matrix, if we want to instantiate it, we have to provide a length for each dimension. So in this case, we say that we want a new two-dimensional array of integers, where the first dimension, so the first array in this would be 3 elements long, and the second dimension, so the second element of this array is 4 elements long. The same goes for the float matrix. In this case, the first array would be 8 elements long, and the second array would be only 2 elements long. And for the cube, it's exactly the same. When we instantiate it, we have to provide a length for each dimension of this array. Now, there is one important thing that I still want to underline before we actually go further. A very common type of array that we would probably use is a 2D array where the length of the two arrays is exactly the same. So in this example, like for the int matrix, you could have a new int array of 4 and 4. So this type of array is very, very common. And for instance, if you would like to model a chess engine, as said, you would have to probably represent the chessboard as an integer array of length 8 and 8. So each of the arrays in this 2D array would have the exact same length. And that should then actually do it. But I guess it's enough with the talking. So let's get here back to Visual Studio and try to also work things here. Now, as said, what we can do here is let's declare an array first, and we will work only with two-dimensional arrays because, as said, those are the most common type of arrays that you will encounter while programming. So what we can see here is that we declare a two-dimensional array because we just use one comma. We can give it a name, my array, and then we have to also, or if we want, in this case we want to instantiate this array. So in this case, as said, we have exactly the same syntax that we had also for regular arrays. The only difference is that we have here to provide a length for each dimension of these two-dimensional arrays. So let's start with an array of 2 and 3, which means that in this 2D array, we will have the first array that would have 2 elements and the second array that would have 3 elements. We can also imagine this as, for instance, a 2D array or a matrix that for instance, 2 will be the number of rows and 3 will be the number of columns. Good. Now, here, for instance, what we can do is then we can assign values to each of the elements. And as said, and here I would use some code that I have already written, but if you want to code along, just please feel free to stop the video and write this for yourself. So what we have done here as a next step, we just wanted to assign values to each element of this array, because here, as integers are value types, all elements would be 0, because this is the default value for integers. Now, as said, if we want to assign values, we would have actually to identify each element in this two-dimensional array by using the 2 indexes that we currently care about. So it would be 0 and 0 for the first element, 0 and 1 for the first row and the second column, 0 and 2 for the first row and third column. Now, exactly the same we have here. Like, for instance, we have 1, which means that this is the second row and this is the first column, second row, second column, which will have this value, and second row and third column, which will have this value here. So actually, what we can do here right now is that we can go one step further. And what we want to do here is we want to print this array on screen. Now, if we want to do that, we can simply do it as the following. So we will have a for loop. And this is actually a very, very common thing when working with two-dimensional arrays. And this type of questions will also come most probably in an interview that you would probably face later, is that you would have to do different type of calculations or very simple stuff on a 2D array. So the question is, how do you do that? And as we have seen, most of the cases when you get exercises with regular arrays, it means that you need a for loop. But what it means for two-dimensional arrays is that in most cases you would have, or you would need, a nested for loop. And why is this like that? Because we would need a loop that first goes through all the rows. So let's call this indexer, in this case row, to be more precise and clear. Then row should be smaller or less than. And here is one interesting thing, because as said, basically what we have here is we have rows and we have columns. So which is the length of each element here that we want to go through? Basically what this actually means is that we would have to get the length of each the array that actually are part of this two-dimensional array. So in this case, I can simply use my array and say here, for instance, we have this method getLength. And this method getLength, we can also specify, if we hover the mouse here, we will also get the information that it gets a 32-bit integer that represents the number of elements in the specified dimension. So which means that if we look here, we have to specify as an argument the dimension. So what is the dimension for which array in this 2D array do we want to get the length. So in this case, if we think here about the rows, we will say that we want from the first array, and of course we then have to increment row. Okay, and then we would have here once again to go further. In this case, we would have the columns. So let's name this indexer call. Then in this case, what we want to do is that call should be less than my array, then get length. And in this case, we want the second array in this dimension, which is on position 1. And of course, we have to also use the same naming. And that's basically it. In this case, we can just simply take here a console write line and print the array that we have right now. So if we go through here, okay, sorry for that. I have a typo here, should be fine right now. So let's run it again. Okay, so we see here that my array of 0 and 0 is 1, my array of 0 and 1 is 2, my array of 0 and 2 is 3, my array of 1 and 0 is 4, then 5, and then 6. And that's actually it. Now, in this case, everything is okay. So as you can see, but let's do another thing. Let's put here a breakpoint and actually go through all of this and try to understand exactly how iterating through a two-dimensional array works. So right now we start here in this outer for loop, which we have said actually represent the rows that we want to go through. So we want to go actually through all through both of the rows. And while we are in one row, we want to iterate and go through each of the columns. So in this case, we see that here we are on row 0, but then we enter this inner for loop. And here, once again, we get started. So the first element here is 0. So right now we are on the position of 0 and 0. And in this case, it means, or it corresponds to what we have here. So of course, it will print the 1. Then it will increase this number of column. And then in this case, we are at row 0 and column 1. So which means that we are at this position. So let's go here. Okay, now everything is okay. And then we are right now at the position here. We are on the same row. So we are still here on exactly the same row, but we have changed the column and it has the index of 2 in this case. So which means that it is the third column, which is actually this one here. So now we also write this into the console. If we open the console, of course, we can see that. So let's write it and check again. So we have written this. And now what happens? Let's check here what happens now. So right now we increase the counter. So it's how a for loop works. And then suddenly this condition is not met anymore. And then we arrive with the execution of this program here at line 24, which means that we are finished with the first iteration on this outer for loop. So in this case, we increase the indexer here on this outer for loop. We still verify the condition. Row is right now 1 because we are on the second row. We have moved over to the second row. We have done everything we wanted on the first row. And then we go once again into this loop. And here what we have, we encounter once again this inner for loop, and here then we start everything from scratch. So we go through each of the columns of this second row. So right now we would have here the first row, and here we'll have the column 0, which would correspond to this element. Then of course we would write this in the console, we would increment this, and once again we arrive here, and now we are once again on the same row, but we are still iterating through the columns. And in this case, we write what it is in the second column, and then for the third column, and we have it happens exactly the same. Then we just increase once again the count here. This condition is not satisfied anymore, so we go out of this inner for loop. Then we increase the counter of the outer for loop. And in this case, the condition is once again not met anymore. So we exit the entire for loop now. So this is why I wanted to show you this, because it's very important to understand how iteration through a two-dimensional array actually works, because it is a very, very important topic. Now, let's just close this application right now, and let's move here right now to another topic that we would have. And one of the most exercises, or the most common exercises that you could get at an interview for a junior .NET developer, is to simply calculate the sum of all elements of a two-dimensional array or matrix. And this is actually very, very simple. So let's just write here a comment here, calculate sum. And as you would probably already imagine, it's actually very, very easy, because what we have to do is nothing more, nothing less than having this same nested for loop. So let's take it here once again. We'll just copy paste in this case, but if you are watching this, then it would be very, very helpful for you, especially if you are really at the beginning stages and you have just started to learn programming. It would be important to pause the video and write this by yourself. It's very, very important to get accustomed with writing code with Visual Studio and things like that. You can't imagine how important it is. I can't emphasize it strong enough. So what is the only thing that we would have to do here is that we will need an integer, int sum, and we'll put this on 0 at the beginning. So what we'll do here is that, well, each time that we arrive here, instead of printing something in a console, we just want to add here to the sum, because we want to get the sum of for all the elements in these two-dimensional arrays. So in this case, it would be then sum, then plus equals, and then my array. And as said, we have to identify the element that we actually want to add to the sum. And in a two-dimensional array, this is done by specifying the row and the column of the element that we currently want to access. So in this case, well, it would be simply we can use, as those are dynamic and get incremented and start at 0, we can simply here put row and column. And then the only thing that we could do is that at the end, when we finish everything, we can just simply print out the sum to the console, and that should do it. But here in this case, yeah, we don't know exactly the... let's just sum of my array equals, and we place here the sum, and that should actually do it. Okay, we have here the application, and sum of my array equals 21, which I assume should be correct if we add all those elements together. Now, before we wrap this up, this concept of multidimensional array, I just want to go through another exercise that is very, very common if you think about interviews. And that is, as said, that these two-dimensional arrays are also called matrix or matrices. And in mathematics, this is a very, very important concept. And one of the most important concepts is, well, the main diagonal, which is, for instance, 0 and 0, 1 and 1 in this case, and 2 and 2 if we would have another array. So basically, it's the diagonal that goes like this. So from the upper part to the lower part. So this is actually the main diagonal. But you could also try to imagine the other diagonal. However, the idea is that, well, calculating the sum of this main diagonal is actually nothing very complicated. The main concept is exactly the same that we have here, like for calculating a sum, and that we usually have with two-dimensional arrays. We need a nested for loop. Now, the only thing is here that we don't really want to sum all the elements, but we want just to sum the elements that are on that specific main diagonal. So in that case, in this for loop, there is one thing that we have to do. We just need an if, and in this case, what we could do here is, well, if rows, so if the row equals call, so if they are the same, value only, and then we would add to the sum. Otherwise, we'll simply go further. So you see that between the first exercise where we would have to calculate the sum of all the elements and the second exercise where we have to calculate only the sum of the main diagonal, there is actually only one simple thing that we need to add, a simple if check, and we add to the sum only if we are here right now at the same row and call have the same value. So if we run the application, actually it should right now print the sum of the elements on the main diagonal. So let's run the application once again. And in this case, we see that sum of my array is 6. And let's try to figure this out. So as I said, the main diagonal is, an element is placed on the main diagonal if the index of the row is equal to the index of the column. So we would have here on 0 and 0, we have this 1. And on 1 and 1, we have 5. And the sum of those is 6, of course. So it means that this is correct. So only these two elements are taken into consideration when it comes here to this type of thing. So yeah, I guess that this exercise is also correct. Now, before we really wrap up, once again, I just want to emphasize that multidimensional arrays and 2D arrays is not something that you would normally encounter very often when you develop regular line of business web applications, for instance. But 2D arrays or a matrix or tables are a very common concept that each programmer should have a basic understanding of. And this is why I just wanted to go over this concept and see actually and show you here the specificity of working with a 2D array is that whenever you want to calculate something or do any type of exercise on a multidimensional array, you virtually most any time will need this nested for loop, while when working with regular array, most of the times a regular for loop is enough for you. And that's it for this part. This is the whole story of multidimensional arrays. Please keep in touch here because in the next part we will also discuss a very important topic that sounds very easy at the beginning, but I can assure you it can get very, very, very complicated. And this is about strings. So strings is or string is a very important data type in C# that has some very, very important characteristics that each developer should know about. So stay tuned because in the next part we will dive deeper into how we should work with strings. Until then, thank you very much for watching and I wish you the very best.